In early March 1944, a simple silver cylinder lying in a wheat field would reveal more about the outcome of the air war than any single dogfight, and change how Germany saw the industrial war it was losing. March 1944, Rechlin-Latz Airfield, Mecklenburg, Germany. The systematic examination of captured enemy aircraft had become a critical task for the Luftwaffe's Technical Intelligence Service. At the Reich's primary aircraft testing and evaluation center, teams of engineers and test pilots worked to understand every edge the Allies possessed in the air. What they uncovered in the early spring of 1944 fundamentally altered their view of American industrial capacity and the future of the air war over the Reich. A captured P-51 Mustang arrived at Rechlin on March 6, 1944, transported by rail from a crash site near Brandenburg. The Mustang had been shot down 2 days earlier during the first American fighter escort mission to Berlin. The pilot did not survive, but the airframe remained largely intact, giving German technical staff their most complete example yet of the aircraft that was rapidly shifting the balance of air power over Germany. A senior engineer oversaw the initial examination, and the pilot's navigation charts, still in the cockpit, showed the route from an English airfield to Berlin and back, a round trip of well over 500 miles. The evaluation began immediately. German intelligence had been receiving reports of increasing American fighter activity deep over German territory, but the official assessment until then had held that single-engine fighters lacked the range to escort bombers all the way to Berlin. The distance from English bases to the German capital measured roughly 560 miles one way, and standard fighters, even with external fuel tanks, were not believed able to carry enough fuel for such missions while remaining combat effective. That assessment had been reinforced by captured examples of earlier American types, P-47 Thunderbolts and P-38 Lightnings, which had shown limited penetration into German airspace before fuel constraints forced them to turn back. The events of March 4 and March 6, 1944, shattered those assumptions. On March 4, P-51 Mustangs from the 4th Fighter Group, flying their first mission in the new aircraft after a rapid transition from P-47s, escorted a small bomber force to Berlin. Weather and communication problems limited the mission's effectiveness, and only 32 bombers reached the target, but the significance was unmistakable. American single-engine fighters had reached Berlin, engaged in combat, and returned to England. 2 days later, on March 6, approximately 660 bombers attacked Berlin in daylight, escorted by over 150 P-51 Mustangs alongside P-38 and P-47 groups. The escort fighters engaged Luftwaffe interceptors over the capital and accompanied the bombers home. This was not a one-off penetration. The Americans had solved the escort fighter problem. General Major Adolf Galland, one of Germany's most successful fighter aces, who continued to fly combat missions despite his senior administrative role, encountered P-51 formations over Germany and immediately recognized the operational implications. His combat reports, submitted through official channels, stated that American fighters were operating at full combat capability over Berlin, engaging aggressively and showing no obvious attempts at fuel conservation. They were not flying at the limits of their range, they had reserves. This contradicted the Luftwaffe's assumptions. Galland's assessments emphasized the P-51's superior performance at high altitude, where it outmatched both the Messerschmitt Bf-109 and the Focke-Wulf FW-190 in speed and maneuverability above 20,000 feet. At Rechlin, the technical examination focused first on determining how the Americans had achieved such range. Engineers measured the P-51B's internal fuel capacity, 2 wing tanks holding 92 gallons each for a total of 184 gallons in the wings, plus an 85-gallon fuselage tank behind the cockpit, a relatively recent addition to extend range, giving a total internal capacity of 269 gallons. The Packard-built Merlin, a licensed version of the Rolls-Royce Merlin that transformed the Mustang's high-altitude performance, consumed fuel at rates that varied with power settings. At economy cruise, the engine burned roughly 60 gallons per hour. At normal cruise, around 75 gallons per hour. Using these figures, German engineers calculated that with 269 gallons and a cruise consumption near 70 gallons per hour, The P-51B could fly roughly 3.8 hours at a cruising speed of about 300 mph, a maximum range of around 1,140 miles, enough in theory to reach Berlin from English bases and back, but only barely, and with no combat reserves. Yet combat reports showed American fighters engaging in prolonged dogfights over Berlin, sometimes 15 to 20 minutes, and still returning. Combat power settings could push consumption above 100 gallons per hour, which, on paper, should have left the Mustang unable to complete the return journey. The calculations did not explain what pilots were seeing in the sky. The answer emerged when engineers examined the aircraft's wing structure more carefully. The P-51B featured standardized hardpoints under each wing designed for external stores, including fuel line connections, indicating they were made specifically for drop tanks. Drop tanks were not new. German fighters had used them since the Battle of Britain, but what surprised the Germans was the size, construction, and scale of American tanks. Search teams swept the countryside northeast of Berlin, and within days several jettisoned tanks were recovered. 2 arrived at Rechlin relatively intact. The tanks transformed German understanding of Allied methods. Cylindrical and about 108 inches long with a diameter near 22 inches, each tank held roughly 108 U.S. gallons, about 400 liters. 2 such tanks added 216 gallons, extending the Mustang's total fuel to approximately 485 gallons. With that load, a Mustang could fly nearly 6.7 hours at cruise, giving a range exceeding 2,000 miles, comfortably covering the Berlin missions with substantial combat reserves. Even more arresting was how the tanks were made. They were not metal. Beneath the silver paint, German engineers found layers of heavy craft paper laminated with a resinous adhesive. Multiple layers of chemically pulped craft paper, each oriented for strength, bonded with a thermosetting resin cured by heat. Nose and tail cones were formed from overlapping pieces like papier-mâché. Interior surfaces were coated with a cellulose-based lacquer to resist aviation gasoline. Brass fittings were precision machined and well sealed. Wooden anti-slosh baffles prevented fuel surge during maneuvering. The construction was simple, standardized, and suitable for mass production in ordinary paper mills and packaging factories with minimal modification. The implications hit home. These tanks used non-strategic materials, avoided scarce aluminum and steel, and required no skilled metal workers or specialized facilities. Paper and resin could be sourced and produced in vast quantities. Intelligence officers estimated that converting a small fraction of U.S. paper production could yield hundreds of thousands of tanks per month. The tanks were single-use by design. The resin slowly dissolved in prolonged contact with gasoline, making long-term storage filled impractical. But that didn't matter operationally, because fighters were fueled immediately before flight, and jettisoned tanks were expendable. Color coding simplified ground operations: silver for paper tanks, gray for metal ones. Everything about the design reflected an industrial optimization for mass production and operational tempo. By late March 1944, German intelligence traced the origin of these paper tanks to British development begun in 1943 to conserve strategic metals. Manufacturers in both Britain and the United States quickly produced them for RAF and USAF squadrons. What the paper tanks conveyed to German engineers was part technical detail and part strategic truth. American equipment was not always more sophisticated in every component, but it was consistently better manufactured, standardized, and available in vastly greater numbers. Where German designs often excelled in craftsmanship and precision, the American approach prioritized producibility, interchangeability, and output. North American aviation and its suppliers produced Mustangs at rates Germany could not match. By 1944, combined U.S. Mustang output reached hundreds per month, while American aluminum production dwarfed Germany's. The Germans could, in theory, produce similar paper tanks, but their chemical and paper industries were already strained supporting existing military needs. Fuel shortages and industrial bottlenecks meant Germany could not scale production the way the Allies could. The psychological impact of these revelations spread through Luftwaffe circles. The paper drop tank became a symbol of industrial disparity.
Captured tanks were displayed in technical briefings and at a June 1944 exhibition at Rechlin, where Luftwaffe personnel inspected Mustangs, B-17s, B-24s, P-38s, Lancasters, Mosquitoes, and Spitfires, and saw plainly the standardization and mass production that backed Allied operations. Operationally, the consequences were immediate and brutal. One single-engine escorts could accompany bombers to Berlin and back without crippling fuel concerns. The Luftwaffe could no longer rely on escorts turning back before reaching their targets. Intercepts now meant fighting through an escort screen, and losses mounted. By mid-1944, Luftwaffe fighter attrition rates rose steeply. Inexperienced replacement pilots, limited fuel, and the sheer numerical advantage of Allied production conspired to make daylight air operations over Germany increasingly costly.
The technical lessons gleaned at Rechlin thus fed directly into operational assessments, and for many German officers and engineers marked the moment when the strategic balance tipped decisively. After the war, the paper drop tank remained a striking case study in industrial innovation, a simple, inexpensive, single-use solution made from non-critical materials that solved the tactical problem at scale. A few surviving examples now sit in museums, including the National Air and Space Museum, where they stand beside Mustangs as reminders that in modern conflict, production capacity and the ability to craft adequate, mass-producible solutions can be as decisive as technical brilliance. The P-51 Mustang and its expendable paper tanks were not the sole cause of Allied victory, but in March 1944, they crystallized a larger truth. The side that could produce more, faster, and at the scale required by sustained operations had gained an advantage that battlefield skill alone could not overturn. By the summer of 1944, the consequences of that revelation were fully realized in the skies over Europe. American fighter groups, once forced to break off and turn back over Western Germany, now roamed freely from the Ruhr to the Oder River. P-51 Mustangs, fitted with their lightweight paper tanks, escorted bombers on every major raid, and still had the endurance to strafe airfields, trains, and convoys on their return journeys. Luftwaffe pilots began referring to these long-range missions as death flights, because no matter how high they climbed or how far east they flew, the Mustangs were already waiting. For the first time, German air defense had no safe rear area. The very heart of the Reich, once thought to be beyond reach, was now under constant watch from the skies. At the Rechlin Proving Ground, the captured Mustang continued to undergo detailed examination. Technicians documented the laminar flow wing design that gave it superior speed and efficiency, the low-drag radiator system that doubled as a cooling and thrust-generating unit, and the cockpit layout optimized for quick, intuitive operation. Even the radio equipment impressed German evaluators. Powerful, standardized, and crystal-controlled, ensuring clear communication across hundreds of miles. The report compiled from these findings circulated among senior Luftwaffe leadership, including Galland himself. It concluded with a sober statement: "The American war industry has achieved the rationalization of mass production to a degree unmatched by any other nation." For many German officers, that single sentence captured the essence of what was happening to their country. While German factories were still hand-fitting components and customizing every aircraft, American plants in Inglewood, Dallas, and Kansas City were producing Mustangs like automobiles. Every part interchangeable, every bolt standardized. The United States could lose 100 planes in a week and replace them in days. Germany could not replace 10 without halting production elsewhere. The captured paper fuel tanks were not merely a curiosity. They were a message from an industrial giant that had learned how to turn raw materials into air power faster than its enemies could shoot them down. In April 1944, Allied bombing intensified. P-51s, now operating in full strength, began sweeping the skies clean ahead of bomber formations.
They attacked Luftwaffe assembly points, ambushed squadrons as they climbed to altitude, and even strafed airfields during takeoff. Veteran German pilots who had survived since 1940 now found themselves outnumbered and outmaneuvered. The losses were catastrophic. Between January and June 1944, the Luftwaffe lost over 5,000 fighters and nearly all of its experienced aces. Fuel shortages compounded the disaster by late summer. Many German airfields were forced to ration flight hours to a few minutes per day. Meanwhile, in the United States, entire high school classes toured aircraft factories as part of war bond drives. They watched as vast production lines rolled out row after row of identical aircraft, each destined for a specific squadron somewhere across the Atlantic. This level of industrial transparency, where even civilians could witness and understand the scale of the effort, underscored how completely the United States had mobilized its economy for war. The P-51 was not just a weapon, it was a symbol of a nation that had learned to manufacture victory. German engineers at Rechlin continued to test the captured Mustang until early 1945. They flew it against the Bf-109G and the FW-190A under controlled conditions, measuring acceleration, climb rate, and roll response. Every test ended the same way. The Mustang was faster, steadier, and more forgiving. One pilot remarked that it flies like it wants to help you survive. In contrast, the Bf-109 demanded constant control inputs and punished mistakes harshly. For Luftwaffe test pilots, it was an unsettling experience to fly an enemy aircraft that felt safer, smoother, and more advanced than their own. By the time Soviet troops reached Rechlin in May 1945, the captured Mustang lay in pieces. Some of its parts had been taken as souvenirs. Others were studied down to the smallest bolt. But the lessons it taught remained indelible. The paper drop tanks, once dismissed as a trivial innovation, had allowed the Mustang to become the long-range escort that sealed the fate of the Luftwaffe. The skies over Germany, once defended by the finest pilots in Europe, now belonged to an enemy whose strength came not only from courage or technology, but from sheer production power. In the end, the story of the paper fuel tank is more than a tale of engineering. It is a story of industrial philosophy. The Germans built for perfection. The Americans built for abundance. And in modern war, abundance multiplied by efficiency and standardization proved to be the deadliest weapon of all.
After Germany's surrender in May 1945, Allied intelligence teams began combing through the ruins of the Reich, gathering documents, aircraft remains, and reports from facilities like Rechlin. Among the files they recovered were detailed evaluations of the P-51 Mustang, including sketches, performance charts, and lengthy essays on American production methods. The reports revealed an unmistakable sense of reluctant admiration. German engineers had recognized not only the Mustang's excellence, but also the economic system that had made such excellence possible on a massive scale. For the first time, the Luftwaffe's technical officers had seen how a nation's industrial strategy could become a direct weapon of war. The captured files were later used by both Allied and Soviet engineers as post-war studies in industrial warfare. In the Soviet Union, some of the Rechlin reports were translated and circulated among aviation designers who were fascinated by the simplicity of the paper drop tank concept. Soviet planners briefly considered adapting similar disposable tanks for their own fighters, but by the early 1950s, advances in jet propulsion had already made such long-range piston escorts obsolete. In the West, American industry took the lessons of the P-51 era and turned them into doctrine, the idea that every weapon should be not just superior, but easily mass-produced, easily maintained, and easily replaced. Meanwhile, the surviving German engineers who had examined the Mustang went on to contribute to post-war aviation under new banners. Some were taken to the United States under Operation Paperclip, where they worked for companies like North American, Boeing, and Lockheed.
There, they witnessed firsthand the continuation of the same industrial philosophy that had once defeated them. Vast assembly lines, automated tooling, and standardized parts feeding an ever-growing defense industry. For them, the experience was humbling but educational. They had lived through the transformation of warfare from craftsmanship to manufacturing science. In the years that followed, historians would revisit the Rechlin tests as a turning point in the Luftwaffe's understanding of its own limitations. The P-51's arrival did not just mark the moment that Germany began to lose the skies. It marked the moment when the myth of technological superiority gave way to the reality of industrial might. The Luftwaffe had fought brilliantly, but brilliance alone could not replace thousands of lost planes or fuel tanks made from paper that could be produced by the millions. The battle for the skies over Europe had become, in essence, a contest of factories, and by 1944, that contest was already decided. Today, a few of those paper tanks survive, preserved behind glass in museums in Washington, London, and Berlin. Visitors often mistake them for metal until they look closely and see the faint texture of compressed paper under the faded silver paint. They are fragile artifacts, reminders of a time when simplicity defeated complexity, and when the fate of nations could hinge on something as unassuming as a disposable fuel tank. The story of the P-51 Mustang's paper drop tanks remains one of the most striking examples of how innovation and industry converged to change the course of a world war. It demonstrates that victory in modern warfare depends not just on what is invented, but on what can be produced, relentlessly, efficiently, and at scale. When German engineers in 1944 peeled back the silver paint and discovered that the material beneath was nothing but layers of laminated paper, they understood something profound. They were no longer fighting just pilots and machines. They were fighting an entire industrial civilization, one that could turn pulp into power and mass production into mastery. The outcome of that war, and the wars that followed, would forever bear the mark of that realization. In the decades after the war, the legacy of the P-51 Mustang and its paper fuel tanks continued to echo across generations of aviation and military design. The concept of disposable efficiency, building components to serve a single, precise purpose rather than last forever, became a cornerstone of modern logistics. Jet-age military soon applied the same logic to everything from external fuel pods to missile casings and drone components. What the paper tank had proven was that ingenuity did not always mean sophistication. Sometimes the simplest solution carried the greatest strategic weight. Post-war Germany, divided and rebuilding, never forgot what its engineers had learned at Rechlin. Many of those who survived went on to design for civilian aviation, automotive manufacturing, and industrial machinery, applying the mass production philosophies they had once underestimated. Across the Atlantic, American industry took those wartime lessons and turned them into doctrine. The idea that every weapon should be not just superior, but easily mass-produced, easily maintained, and easily replaced. The Mustang itself remained in service long after the guns of Europe fell silent. It flew in Korea, in dozens of smaller post-war air forces, and in private hands as a racing legend. Each aircraft carried within its sleek frame the legacy of that 1944 revelation, that the combination of speed, endurance, and simplicity could change the destiny of nations. In documentaries, museums, and history books, the paper drop tank stands as a quiet hero of that transformation, a fragile, flammable container that extended the reach of air power and symbolized the triumph of quantity allied with quality. For historians, the moral is unmistakable. The P-51 Mustang's paper drop tank tells the story not just of an airplane, but of an idea. That victory belongs to those who can outproduce, outsustain, and out-innovate their enemies. When German engineers in 1944 peeled back the silver paint and discovered that the material beneath was nothing but layers of laminated paper, they understood something profound. They were no longer fighting just pilots and machines. They were fighting an entire industrial civilization, one that could turn pulp into power and mass production into mastery. The outcome of that war, and the wars that followed, would forever bear the mark of that realization. In the decades after the war, the legacy of the P-51 Mustang and its paper fuel tanks continued to echo across generations of aviation and military design. The concept of disposable efficiency, building components to serve a single, precise purpose rather than last forever, became a cornerstone of modern logistics. Jet-age militaries soon applied the same logic to everything from external fuel pods to missile casings and drone components. What the paper tank had proven was that ingenuity did not always mean sophistication. Sometimes the simplest solution carried the greatest strategic weight. Post-war Germany, divided and rebuilding, never forgot what its engineers had learned at Rechlin. Many of those who survived went on to design for civilian aviation, automotive manufacturing, and industrial machinery, applying the mass production philosophies they had once underestimated. Across the Atlantic, American industry took those wartime lessons and turned them into doctrine. The idea that every weapon should be not just superior, but easily mass-produced, easily maintained, and easily replaced. The Mustang itself remained in service long after the guns of Europe fell silent. It flew in Korea, in dozens of smaller post-war air forces, and in private hands as a racing legend. Each aircraft carried within its sleek frame the legacy of that 1944 revelation, that the combination of speed, endurance, and simplicity could change the destiny of nations. In documentaries, museums, and history books, the paper drop tank stands as a quiet hero of that transformation, a fragile, flammable container that extended the reach of air power and symbolized the triumph of quantity allied with quality. For historians, the moral is unmistakable. The P-51 Mustang's paper drop tank tells the story not just of an airplane, but of an idea, that victory belongs to those who can outproduce, outsustain, and out-innovate their enemies. When German engineers in 1944 peeled back the silver paint and discovered that the material beneath was nothing but layers of laminated paper, they understood something profound. They were no longer fighting just pilots and machines. They were fighting an entire industrial civilization, one that could turn pulp into power and mass production into mastery. The outcome of that war, and the wars that followed, would forever bear the mark of that realization. In the decades after the war, the legacy of the P-51 Mustang and its paper fuel tanks continued to echo across generations of aviation and military design. The concept of disposable efficiency, building components to serve a single, precise purpose rather than last forever, became a cornerstone of modern logistics. Jet-age militaries soon applied the same logic to everything from external fuel pods to missile casings and drone components. What the paper tank had proven was that ingenuity did not always mean sophistication. Sometimes the simplest solution carried the greatest strategic weight. Post-war Germany, divided and rebuilding, never forgot what its engineers had learned at Rechlin.
Many of those who survived went on to design for civilian aviation, automotive manufacturing, and industrial machinery, applying the mass production philosophies they had once underestimated. Across the Atlantic, the United States took those wartime lessons and refined them into a doctrine of industrial dominance. American factories, retooled for peacetime, began producing automobiles, consumer goods, and aircraft in unprecedented numbers. The same assembly lines that had built the P-51 now symbolized prosperity, a testament to how industrial strength could shape not only a war, but a world. The Mustang itself remained in service long after the guns of Europe fell silent. It flew in Korea, in dozens of smaller post-war air forces, and in private hands as a racing legend. Each aircraft carried within its sleek frame the legacy of that 1944 revelation, that the combination of speed, endurance, and simplicity could change the destiny of nations. In documentaries, museums, and history books, the paper drop tank stands as a quiet hero of that transformation, a fragile, flammable container that extended the reach of air power and symbolized the triumph of quantity allied with quality. For historians, the moral is unmistakable. The P-51 Mustang's paper drop tank tells a story not just of an airplane, but of an idea, that victory belongs to those who can outproduce, outsustain, and out-innovate their enemies. When German engineers stood around that silver-painted cylinder in the spring of 1944, they were not merely examining a fuel tank. They were witnessing the material proof that their nation's war was already lost, not in the skies, but in the factories that fed them. The fragments of that captured P-51 and the reports written in the dim offices of Rechlin remain among the most revealing documents of the Second World War. They show how technology, industry, and strategy converged to decide the fate of empires. And they remind us that behind every great weapon of war lies something greater still: the human ability to create, to adapt, and to mass-produce ideas that change the course of history. After the war, the lessons uncovered at Rechlin would ripple far beyond the ruins of the Third Reich. For decades, the captured reports, photographs, and surviving parts of the P-51 Mustang circulated among engineers, historians, and military planners, each recognizing the deeper meaning behind what the Germans had discovered in 1944. The story was not simply about a new aircraft or a novel type of fuel tank. It was about how industrial systems could determine the fate of nations. In the devastated landscape of post-war Germany, a few surviving engineers who had examined the Mustang were quietly recruited by the Allies. Some were taken to the United States through Operation Paperclip, while others were absorbed into Soviet research institutes. Both sides of the emerging Cold War sought the same thing: a blueprint for the kind of industrial organization that could sustain modern warfare. In Washington and Moscow alike, the phrase "production capacity as a weapon" became a guiding principle. The Mustang's paper drop tank, once dismissed as an expendable accessory, became a symbol of how logistics and design could merge into strategic power. By the late 1940s, these lessons were already being applied in new forms. The United States, now unrivaled in air power, adapted the principle of the Mustang's efficiency to the jet age. Early jet fighters like the F-80 Shooting Star and F-86 Sabre borrowed the same focus on simplicity, reliability, and modular production. Standardized parts, interchangeable components, and easily replaceable systems became the foundation of American aerospace design. Across the ocean, the Soviet Union, though initially lagging, rapidly learned to emulate this model. Within a decade, the same logic that produced the P-51 would manifest in the mass production of MiG jet fighters, nuclear bombers, and ballistic missiles. The race for industrial supremacy, once fought in propeller-driven dogfights over Europe, had evolved into a global competition for technological and manufacturing dominance. Meanwhile, the Mustang itself gained a second life. Many of the aircraft that had survived the war were sold to smaller nations rebuilding their air forces. They flew in South America, the Middle East, and Asia. In the Korean War, P-51 Mustangs returned to combat once again, this time against Soviet-built jets. Though outclassed in speed, they remained valuable for ground attack missions, where their long range and rugged design proved irreplaceable. Even as newer jet aircraft replaced them, pilots spoke of the Mustang with reverence, not only for its performance, but for what it represented: the perfect balance between engineering brilliance and manufacturing genius. In museums across the world, today visitors can find examples of those paper fuel tanks, their silver coatings faded and cracked, their inner layers of resin-hardened paper still intact.
To the casual eye, they seem insignificant, fragile relics beside the steel and aluminum giants of the era. But those who know their story understand that these humble tanks carried more than fuel. They carried the concept that won the I war, a weapon of endurance born not from exotic materials or secret alloys, but from practicality and mass production. For the Luftwaffe, the discovery of these tanks in 1944 was a moment of shock and clarity. At that point in the war, German engineering still operated on principles of precision craftsmanship, producing machines that were often ahead of their time, but slow and expensive to build. The Allies, on the contrary, had embraced a brutal efficiency, good enough, fast enough, cheap enough to overwhelm the enemy through sheer numbers. The Mustang's paper drop tanks crystallized that difference. They represented a mindset where perfection was sacrificed for victory, where every decision, from material selection to assembly speed, served the goal of getting more planes in the air faster than the enemy could respond. Historians later noted that this industrial philosophy, the marriage of simplicity and scale, did not end with the war. It became a cornerstone of post-war American industry. The same assembly lines that produced Mustangs were retooled to build automobiles, consumer appliances, and civilian aircraft, propelling the U.S. into an era of unmatched economic growth. Germany, too, absorbed the lesson. When the nation rebuilt in the 1950s, companies like Volkswagen and Siemens adopted mass production methods inspired by American wartime practices. The legacy of that 1944 discovery had quietly reshaped the modern world. As time passed, the story of the paper tank faded from public memory, overshadowed by the dramatic battles of D-Day, the atomic bomb, and the fall of Berlin. But within circles of aviation historians and engineers, it remained an enduring example of how innovation often comes not from complexity, but from clarity of purpose. The Mustang's drop tank taught us that in war, the simplest idea, when multiplied across an entire industrial system, can change the course of history. In the 1960s and 70s, documentaries and technical analyses revisited the Rechlin tests, piecing together the original reports, interviews, and surviving artifacts. The tone of those studies was not triumphalist, but reflective. They portrayed the German engineers as professionals who, even in defeat, recognized excellence when they saw it. Their writings conveyed respect for the Americans' ability to merge science with production, technology with organization, and design with strategy. The conclusion they reached was both simple and devastating. The war had not been lost in the air, it had been lost on the assembly line. Today, the legacy of that realization still resonates. Every modern fighter jet, every drone, every logistics system owes something to the lessons first learned from that silver-painted paper tank lying in a German field. It's a reminder that the true power of technology lies not just in innovation, but in the ability to make innovation accessible, repeatable, and unstoppable. The P-51 Mustang, once a single-engine escort fighter, became more than a machine. It became a symbol of a civilization that had learned to turn industry into strategy. And in that transformation lies the enduring truth of modern warfare, that no matter how skilled the pilot or how advanced the design, victory ultimately belongs to the nation that can build, supply, and sustain the fight beyond exhaustion. When the engineers at Rechlin peeled back the layers of resin and paper in 1944, they saw not just a fuel tank, but a mirror, a reflection of a future they could not match, a vision of how wars would be fought and won in the industrial age. That moment marked the end of one era and the beginning of another, a world where machines would be measured not only by their performance, but how fast and how many could be built. And so, in the quiet halls of museums, behind glass cases where sunlight glints off the dull silver of aging paper tanks, history whispers the same lesson once more. It was not the strongest aircraft or the most skilled pilots that decided the skies over Europe. It was the power of an idea, the mastery of production, and the realization that in the modern world, victory belongs to those who can make more of everything faster than anyone else.